Today we are going to discuss about how force acting on bones decide the various fracture pattern in orthopedic and orthopedic practice. So let's jump into the compressive force. When a compressive force is applied on a bone or when there is axial loading, it can cause an oblique fracture pattern, can cause a separate butterfly fragment, or it can cause severe bone combination as shown in the figure. So revising the compressive force, it can cause oblique fracture, it can create a butterfly fragment, or it can create a severe combination in the long bones. So the one type of force that acts on the long bone is a compressive force, and we can see it can create variety of this pattern. Now moving on to the tensile force. When a tensile force is applied on a long bone, it can cause a simple transverse fracture. We can understand it by the mnemonic T for tensile and T for transverse fracture. Now moving on to the next force, the bending force. When a bone is bent, it creates force on two cortices. The direction where the bone is bent, it creates a compression, while the bone cortex which is stressed, it creates a tensile force, resulting in variety of fracture pattern following application of bending force. So bending force can create a fracture pattern that is indicative of a compressive force, fracture pattern that is combination of tensile force, or a fracture pattern that can be a combination of either of compressive force or the tensile force. So we have to understand how bending force acts on the pediatric bone. In a pediatric bone, there is a thick periosteum, so the force transmitted is absorbed by the periosteum, and the fracture pattern that can occur in a pediatric long bone can be incomplete. So let's discuss or let's jump into this incomplete fracture pattern created when a bending force is applied to a skeletally immature bone or the bone where they are flexible. So we can guess that we have already heard about them in literature, and they are named as green stick fracture, the plastic deformation, or the buckle fracture, or the torus fracture. So the incomplete fracture due to bending force on immature or flexible bones are green stick fracture, or it can be a plastic deformation, or it can be a torus or a buckle fracture. So to understand them in detail, let's see a figure or an illustrative figure how these fracture patterns are recognized. So when a bending force is applied on a long bone, it can cause a green stick fracture. So what is a green stick fracture? Let's dive into this picture to see it. A green stick fracture is indicated by an incomplete fracture line that does not involve both the cortices in either of the AP view or the lateral view. Now moving on to the another figure where we will try to explain you the plastic deformation. In plastic deformation, there is no obvious fracture line, but the bone shape is deformed. This can be evaluated by using various radiographic line that is defined, or by seeing it clinically where the arm, forearm, or limb is deformed but there is no obvious fracture line. These fractures are addressed with traction and cast application after correction of deformity. Another peculiar type is a buckle or a torus fracture, where there is a simple buckle involving a unicortical area of a bone. It can involve only a single cortex, and these are oftenly missed. So, how do we diagnose this buccal fracture? We have to look at them carefully. Thank you.